Hello everyone, welcome back to this channel. So today we are going to discuss some questions from the distributions of probability. Okay, first question. Which of the following base defines a Bernoulli distribution? What is a Bernoulli distribution? If you throw a coin, you will either get head or you will get tail, right? So we can say either success or failure. And when the trial is done only one time, so it is one time and two outcomes. That means this is a Bernoulli distribution. Okay, now let's read this. A distribution that models time between events. Time between events means exponential distribution. We discussed in our last class that it will work until failure. A distribution of multiple trials with two outcomes. Two outcomes is fine, but not multiple trial. When it becomes multiple trial, then it will become binomial distribution. Okay, so this is also not correct. A distribution of a single trial with two outcomes. That's what we have discussed. Single trial, two outcomes. A distribution with many possible outcomes per trial. This means multimonial distribution. That means here trial is also multiple times and the outcomes are also multiple types. Okay. Let's discuss all of them by an example. So let's summarize the thing. Bernoulli, binomial and right. So Bernoulli means one trial and two outcomes, either head or tail. Fine. But when multiple trials and two outcomes, that means you are throwing a coin multiple times, but outcome will always be two, either head or tail. Multimonial is multiple trials and multiple outcome. Example is, let's say you throw a die. So your outcome is from 1 to 6 and you throw it multiple times. So let's say you throw a die for 12 times. Right. So first time it may be from 1, 2, 3, 4, 5, 6. Second time it may be from 1, 2, 3, 4, 5, 6. This way it will continue 12 times. So you are doing multiple trials and multiple outcomes. Okay. So you understand the difference between these three. Second question. Which of the following defines a binomial distribution? Just we have understood that binomial distribution means distribution of the number of success in a fixed number of independent Bernoulli trials. When it becomes multiple, it becomes binomial. Okay, outcome is only two. Continuous distribution of values between 0 and 1. What does it mean? Which kind of distribution? This is continuous uniform distribution. Right, because it is always between 0 and 1, uniformly distributed. Why continuous? Because it may be 0.2, 0.3 like this. Okay, if it was 1, 2, 3, then we can say discrete continuous. Clear? Third one, time between random events, exponential distribution. Total number of events in a fixed interval, that is always Poisson distribution. Right? Fine. Next question. A coin is flipped once. What is the probability distribution of this event? Flipped once. So it may be head or it may be tail. So one trial, two outcomes. Tell me the definition. One trial, two outcomes means it will be Bernoulli distribution. Fine. A coin is flipped 10 times. Okay, so multiple trial. Fine. Which distribution would model the probability of getting exactly 4 heads? And in each trial you will get either head or tail. So the concept is same, that is binomial. Now you roll a fair 6-sided die 12 times. That's what we have just discussed. What is the probability model that describes the number of times each face appears? Multiple trials and multiple outcomes. So it will go for multinomial distribution. Which of the following distribution is continuous? Binomial? No, binomial, what are the outcomes? 0, 1. This is not continuous, discrete, right? So Poisson distribution, normal, Bernoulli. Normal is the continuous distribution. Okay, this is also 0 or 1. Poisson is fixed within a time interval. Okay. Now next question. You are modeling the number of calls arriving at call center per minute. When the time concept is there, then you can easily say this is Poisson. Because in a fixed time interval, you are trying to predict the calls arriving at the call center, right? The lifetime of a light bulb, exponential. A machine produces parts with lengths evenly spread between 4 and 6 mm. This you can easily say this is uniform because it is evenly spread, right? 6 cm. What is the variance of Bernoulli distribution with P? See, let's discuss mean and variance. I will just tell you the formula. Mean equals to, for Bernoulli means single trial multiple outcomes. So let's say first outcome is head, and head is your success. So your mean value will be P into 1 plus not getting success. So 1 minus P into 0. Not getting success means 0. So 1 minus P probability into 0 equal to 0. So it will be ultimately P. So the mean value is P, or we can say this is the expectations of X. This is P. Okay. So if anybody asks you what is the mean value of Bernoulli, you can say P. But what is the mean value of binomial? See, this is the same thing but happening multiple times. So if it is happening n times, then our mean will be n into P. Fine. Now what is variance? Variance is P into 1 minus P for Bernoulli. And same things for binomial, it will be n into P 1 minus P. Okay, this is the formula you can apply and you can solve this. What is the variance of Bernoulli distribution with P equal to 0.3? See, variance for Bernoulli, that is P into 1 minus P. The probability of getting and probability of not getting. That is the variance. So 0.3 into 1 minus 0.3, which is 0.7. So 0.3 into 0.7 equals to 0.21. Fine. Okay, now the next question. A binomial experiment has n equal to 5, p equal to 0.2. What is the expected value? Expected value means we can say this one, mean. So for mean for binomial is n into p. So we can write n into p. Here 5 into 0.2, 0.1. Okay. For Bernoulli, this will be only 0.2. For binomial, this will be n into p. Clear? So for Bernoulli, the expected value is p. For binomial, n into p. Variance p into 1 minus p. For binomial, n into p into 1 minus p. Okay, so we have discussed all the questions. Now if you want to read the theory part, then you can simply go here and click on these topics and statistics. Here I have discussed these things in details, so you can study from here. The link of this blog I will post in the description box. Okay, so meet in our next video. Till then, bye, happy learning.